Hello students, in today's session of moving charge and magnetism, for the very basic concepts will be cleared using illustration. In earlier session, we have also studied all these things which you can review on Sethi Swift Learn. I will also like to request अगर अभी तक आप YouTube चैनल Sethi Swift Learn के साथ नहीं जुड़े and if you like the contents, please subscribe and share with your colleagues and friends. Now, let's start with the concept with illustrations. Question is that is concept applicable in today's session is path of a charged particle in uniform magnetic field. You know, Fm equal to Q V cross P. V cross P force. Magnetic force. Magnetic force experienced by the charged particle, positive charged particle, is given by this formula. So V is the velocity of the charged particle enters in uniform magnetic field, right? In that case, F equal to Q V B sin theta. Theta is angle between V and B. Angle between V and B, right? And direction of magnetic force, direction of magnetic force Fm is given by Fleming's left hand rule or right hand palm rule. Right hand palm. Right hand palm rule. Now there are three cases. Path followed. Followed by charged particle when entering the uniform magnetic field. Theta equal to 0 or theta equal to 180 degrees. This is a case 1. In that case, Fm equal to 0. That is, charged particles moves in the undulated, right? Second, if theta equal to 90 degree, then it follows circular path, as F perpendicular to B. F perpendicular to B. As F perpendicular to B. In this case, centripetal force is provided by magnetic force, right? Now, therefore, Fm provides mv square by r, that is qvb. Then r comes out to be this v goes mv over qv. Now, as kinetic energy given by half mv square multiplied with half m square V square by m. Therefore, P square by 2m equal to K. Therefore, P equal to twice m K. Also, potential difference work done by periodic charge. Therefore, K is also given by Q into P. Using all these things, using all these things, R can be written as mv upon dq or P upon dq or twice mk under root upon dq or twice m qv upon dq. Depending on the requirement, we can use anyone. Depending on the requirement, we can use anyone, right? And one is time period of something. Time period. You know, speed equal to distance upon time. The time period t will be equal to distance in one position 2 pi r divided by the velocity. 2 pi r की जगह पुट कर दिया हमने mv upon dq into v. This is so time period 2 pi m by q. From this f equal to 1 by t and omega equal to 2 pi f. We can find any relation. This is regarding the path followed by the charge particle when it moves at angle theta equal to 90 degree, right? Third case, theta is not 0 or a 180. Theta is not 0, 90 degree, and theta is other than this. In that case, what will happen? Resolve velocity in two components. One is V parallel to magnetic field, V cos theta, one V perpendicular to V sin theta, right? This component responsible for straight motion. This is responsible for circular motion. Combined effect is path followed is helical. Path followed is helical. Path followed is helical, like this. Right? One term in this case, pitch of helix. Pitch is, that is the distance. Distance is given by horizontal component velocity V cos theta into time period. V cos theta into time period is 2 pi m by dq. 2 pi m by dq. This is all regarding the concepts applicable when charge particle enters in uniform, that it follows the path. Path किस तरीके से travel करेगा, this I have explained here in detail, right? Next question. Question is, two particles A and B, this is A, this is B, of masses m and v respectively and having the same charge are moving in a plane. A uniform magnetic field exists perpendicular to this plane. The speed of the particles are v and vp respectively, and trajectory are shown in the figure. This is the figure. In this case, Ra is greater than Rb, right? You know When a charged particle enters in uniform magnetic field at an angle theta, then R equal to mv by bq or p over pq or twice mk over bq or twice mq into v upon bq. You have to pick up according to the requirement of the question. In this case, charge is same, and B is same. Both will be consumed in constant of proportionality. Constant of proportionality, right? Now, in this case, which will be applicable? Mass is same, having the same charge and moving the plane uniform vector perpendicular to the speed of the particles v and vb, and the trajectories are shown in the figure. In this case, R equal to mv over bq. V is same, so R proportional to charge is same proportional to mv, as R is greater than RB. Therefore, MA, VA is greater than MB. We check the option which is the correct option. B option is correct. Option B is correct. Option B is correct. Right? Next question. Question is, a proton, a deuteron and alpha particle having the same kinetic energy are moving in a circular trajectories in a constant magnetic field. If Rp, Rd and R alpha denote respectively the radius of the trajectory of these particles, then we have to pick up one of the correct answer. Again, concept applicable is when a charged particle enters in a uniform magnetic field, it follows a circular path of theta is 90 degrees. R is given by mv by bq or p by bq or twice mk by bq or twice m q into v upon v. Pick up any as per the requirement. Now given is proton, deuteron have the same characteristics. K is same, B is same, K is same, B is same. Then this concept will be applicable. Therefore, R will be proportional to under root m by q. Root m by q. This is constant proportion में consume कर दिया, this को constant proportion में consume कर दिया. Therefore, R alpha is to R deuteron is to R proton equal to R alpha mass under root 4 divided by 2 is to deuteron under root 2 upon 1 is to under root 1 upon 1. That comes from 2, 1 is to root 2 to 1. Means R alpha and R alpha equal to R cube. And RD is greater than R alpha and RP. Means pick up the answer which is correct. R equal to R alpha. This is correct, and RD is greater than. A option is the correct option. A option is correct. Option A is correct. Right? Next question. Question is, two particles X and Y having equal charges after being accelerated through the same potential difference enters a region of uniform magnetic field and describes circle path of radii R1 and R2 respectively. Ratio of masses X and to that of Y is. Four options are given to one of the options is correct. Again, radius of circle path when charged particles move in a magnetic field at an angle theta to the magnetic field. That is mv over r dq equal to p over dq or twice mk over dq or twice m qv on dq. Pick up one of the correct which is to be applicable. In this case, V is same, Q is same, V is same. V is here, Q is here. This will be, and V is also same. All will be consumed in constant of proportionality. Constant of proportionality. Therefore, R proportional to under root M. Therefore, what is given to you? M proportional to R square. Mx over My equal to R1 over R2 or this. This is the answer. Check up. C option is correct. Option C is correct. Right? Now, I will request, if you are new to my YouTube channel, Sethi Swift Learn, please like and subscribe to my channel, press bell icon to receive updates on concept building videos. Thank you.